Hello students, welcome to my channel Foundation Mathematics. In this video, I will discuss a very important sum from the topic Maxima and Minima from Applications of Derivatives. Let us first read the sum. Show that the semi-vertical angle of a right circular cone of given total surface area and maximum volume is sine inverse 1 by 3. Now, if you look at the figure, you will understand that this alpha is the semi-vertical angle. Let us denote the axis by AB and say BC is the radius of the base of the cone. You are given the total surface area of the cone. That means this is the quantity which is fixed. It is not changing. And you have to show that you will get maximum volume of the cone only when the value of alpha is given by sine inverse 1 by 3. So for that, let us make the following assumptions. We assume the base of the cone, the radius of the base of the cone to be r units. So let the radius of the base of the cone be r units. What you have to maximize? You have to maximize the volume, and the volume will be maximum only when the semi-vertical angle is sine inverse 1 by 3. That is, the value of alpha is given by sine inverse 1 by 3. This is what you have to show. So you take the slant height, that is this, as L. So let the slant height be L units and let the height of the cone is AB. Let the height be H units. And of course, we have taken the semi-vertical angle to be alpha. Let the semi-vertical angle is alpha. Let the semi-vertical angle be alpha, right? So what is sine alpha? This is obviously 90 degree. So if you look at this figure, if you look at the triangle ABC, obviously sine alpha is given by perpendicular by hypotenuse, right? So this is basically BC by AC. So this is going to be R by L. So we will have to find out the values of R and L such that sine alpha becomes 1 by 3, right? So let us first apply Pythagoras theorem. Here again you see we have three variables. We have H, L and R. Okay. So we will try to represent two variables in terms of the third one. So let us first apply Pythagoras theorem in triangle ABC. So in triangle ABC, if we apply Pythagoras theorem, what do we get? We get AC square is equal to AB square plus BC square. So that means L square is equal to H square plus R square, right? So from here you can write H square equal to L square minus R square. Let me write this as 1. Now what are the expressions for total surface area of a cone and the volume of the cone? Total surface area is given by, let me denote this by S. Total surface area S is given by curved surface area, that is pi r L plus the area of the base, which is pi r square. So we can write S as pi r L plus pi r square. Let this be 2. And what is the volume of the cone? Volume, which can be denoted by V, is 1/3 pi r square h. So keep in mind that this is the thing which has to be maximized. The volume of the cone has to be maximized. So from 2, since S is given, it is given that the total surface area is fixed. Since S is given, and I told you that I would like to represent both H and L in terms of R, what can we do? We can make L the subject of the formula. So from 2 we can write L equals to S minus pi r square by pi r. Let me write this as 4. And obviously from 1 we have h square equal to L square minus r square. So we can definitely write h as root over of L square minus r square. We will make these substitutions in the third expression that we have got. So we will have V entirely in terms of R now. So V becomes 1/3 pi r square, and in place of h we can write root over of L square minus r square. So what is L? L is given by S minus pi r square by pi r. Now here we have h equal to root over of L square minus r square. So in place of L square I will substitute what I have got in 4. So that is S minus pi r square by pi r whole square minus r square. Expand this. This is by using the formula for a minus b whole square. So we have s square minus 2 pi r square s plus pi square r to the power 4. This whole thing is divided by pi square r square minus r square. So if we simplify further, we are getting h equal to root over of a square minus 2 pi r square s plus pi square r to the power 4 minus pi square r to the power 4, and this whole thing is divided by pi square r square. So as you see, pi square r to the power 4 is getting cancelled. This part is getting cancelled. So we have h equal to root over of a square minus 2 pi r square s by pi square r square units. Now substituting for h, we have a simplified form for v only in terms of r. So it is v equals to 1 by 3 pi r square, and in place of h we are writing this. So we have root over of a square minus 2 pi r square s by pi r. We take the square root of this quantity and we are getting pi r. So it gets cancelled. Ultimately we have v equals to r by 3 into root over of a square minus 2 pi r square s. So we have got v only in terms of r, and we will find the value of r, which is going to maximize the value of v. So here, since we have a square root, let us square both sides. If v is maximum, then obviously v square will also be maximum. So let us write v square as v dashed. This is equal to v square. So this is going to be r square by 9 into a square minus 2 pi r square s. So we are getting v dashed equal to r square s square by 9 minus 2 pi r to the power 4 s by 9. Like I told you, v dashed is also an expression entirely in terms of r, because this s is given to us. This s is fixed. This is not changing. Now, maximum value of v implies maximum value of v square as well. So we find out dv dashed dr, that is the first order derivative of v dashed with respect to r. So we have 2r s square by 9 minus 8 pi r cube s by 9. And similarly, we find out the second order derivative as well, that is d2 v dashed dr2. So this gives us 2 s square by 9 minus 24 pi r square s by 9. So for critical points, what do we have to do? We equate this with 0. This is equated with 0. So for critical points, we have dv dashed dr equals to 0. This is going to give us 2r s square by 9 minus 8 pi r cube s by 9 equals to 0. So we will get r in terms of s. Since s is given to us, s is fixed, we can find out r entirely in terms of s. So a little bit of simplification will give us s equal to 4 pi r square. So from here we can write r equal to root over of s by 4 pi. Now we have to check for the value of the second order derivative at this value of r, whether this is coming out to be negative. So in the second order derivative, what we do is we substitute for r. So now second order derivative, that is d2 v dashed dr2 at r equals to root over of s by 4 pi is obtained by substituting the value of r, and we will just check whether this is coming out to be positive or negative. If it comes out to be negative, then we can clearly say that v dashed is maximum at this particular value of r. So we have 24 pi r square is s by 4 pi whole by 9, and if we simplify, we are getting 2s square minus 6s square by 9, that is minus 4s square by 9, which is clearly negative. So obviously v dashed is going to be maximum at this particular value of r, that is v dashed will be maximum, rather v will be maximum when r is root over of s by 4 pi. Now it is time for us to find the value of L. We have seen previously that the expression for L is S minus pi r square by pi r. We have done this calculation before. So just substitute for r here. We have S minus pi into S by 4 pi, which is the value of r square. This whole thing divided by pi r. So simplification gives us 3s by 4 pi r. Now you can substitute for r in the denominator also. So we have 3s by 4 pi into s by root over of 4 pi. So again simplification gives us 3 into root over of s by 4 pi. So obviously we have evaluated r and we have evaluated L, which is equal to 3 into root over of s by 4 pi, and previously only I have discussed the value of sine alpha, where alpha is the semi-vertical angle. Sine alpha is given by r by L. So just substitute for r and L here and evaluate sine alpha. So sine alpha is r by L. The value of r is s by root over of s by 4 pi, and that of L is 3 into root over of s by 4 pi. So what do we see? We see that root over of s by 4 pi gets cancelled both in the numerator and the denominator, and thus we are getting sine alpha equals to 1 by 3. This gives us alpha equals to sine inverse of 1 by 3, and this is what we had to prove. So the volume will be maximum only when the semi-vertical angle, that is alpha, is given by sine inverse of 1 by 3, and hence we have proved this. This is a very important sum. See, this sum is full of calculations. So be very careful when you are doing the calculations in the intermediate steps. I hope you have found this video useful. Thank you for watching.